Welcome back to Pac-Man. We've done a great job so far in moving Pac-Man inside the maze. Now here in this video and probably the next, we're going to take even a harder job to make Inky, the enemy, the ghost, move on its own, as if moving Pac-Man wasn't hard enough. So let's waste no time. Let's click on the Inky sprite and let's bring in the when flag clicked block. Now, both Pac-Man and the enemies will have that speed and direction logic. So I'm going to create some variables. I'm going to make a variable called speed for this sprite. And I'm going to set that speed to 2, much like Pac-Man. And I'm going to create another variable called direction. Again, private to this sprite. And direction will have the same logic as Pac-Man. So I'm going to set the direction to stay. Besides that, I'm going to bring the ghosts to a given set of coordinates. I'm going to put -16 and -16, which is at the corner of the cage right over here. And I'm going to point in direction 90. So that's simple enough. Now, the enemies will move with a very similar logic to Pac-Man. That is, they will also change their x and y coordinates depending on what value that direction variable has. So I'm going to bring this forever loop and drag it and drop it onto the Inky sprite. So I'm going to snap it here right below. So changing the x and y coordinates are fine, but the pointing in direction is not applicable to the ghosts, so I'm going to pull them out and delete them. I'm actually going to keep this teleportation block because the ghosts are also able to teleport across the edges of the maze. I'm just going to remove the pointing in direction blocks. So I'm going to make some changes here. And I'm also going to remove this changing of the costume logic because it's only applicable to Pac-Man. So now only the ghost movement here we have when flag clicked. Now, as I mentioned at the beginning of the game, the enemies also have this collision costume that Pac-Man does, so that they can also stop when they hit the wall. So I'm going to go to Pac-Man and I'm going to drag this motion script, so the setting of the direction and the collision logic, I'm going to drag it onto the enemy. So I'm going to drag it here and I'm going to remove a few bits. First, I'm only going to keep the collision logic, and the decision of the direction based on user input I'm going to remove because they don't respond to user keys. So I'm only going to keep the collision logic inside. So if they are able to change their direction, so the same condition as Pac-Man, if x position mod 16 is equal to 0 and same for y, they're pointing in direction 90, which they already do, and switch their costume to collision. And they have the same collision detection logic with the color as touching color, and back switch costume instead of man 1 to Inky, because man 1 is specific to Pac-Man. Alright, so very quickly we already have a bunch of code that will move the sprite on the screen depending on its direction, and we already have the collision logic with the wall. But while Pac-Man was deciding its direction based on user input by pressing the up, down, left, and right arrow keys, the enemies will decide their direction on their own. So this is going to be very interesting. For that, I'm going to create two variables. So I'm going to make a variable that I'm going to make private to this sprite, and I'm going to name target x. And I'm going to make another one called target y. So target x and target y will be the coordinates of where the enemies are going to go. And the goal for the ghost is going to be to get to that point, denoted by target x and target y, as soon as possible. So they will decide what direction they're going to use so that they minimize the time to get to that point, denoted by target x and target y. And I'm going to continually set target X and target Y to be the coordinates of Pac-Man so that the ghosts will follow me. To keep track of the direction that Inky will choose to minimize its time to get to me, to Pac-Man, I'm going to create another variable private to the sprite, and I'm going to name it desired direction. So this desired direction will be the direction that will theoretically minimize the time between Inky and Pac-Man. Alright, a small explanation break. Let's assume that our very favorite Pac-Man is right over here on the screen at the coordinates target X and target Y. So this is the coordinates that our ghost will tend to go to. And our ghost is right over here at coordinates X and Y. Notice that the horizontal distance between the ghost and the target is less than the vertical distance between the ghost and the target. So in this case, we will make the ghost go horizontally first before moving down towards Pac-Man. Now, we will decide to move ghost to the left because the target X is less than X. So we will make the ghost go to the left. Now, let's assume another case where our Pac-Man is here at the coordinates target X and target Y, and our ghost is here to the left of Pac-Man at the coordinates X and Y. Now, as before, the horizontal distance between the ghost and the target is less than the vertical distance between the ghost and the target. Now, because the coordinate X of the ghost is less than the coordinate X of the target, we will make the ghost go to the right. And similar for the other two situations that we might get into. So say, for example, that Pac-Man is here at target X and target Y, and the ghost is to the up right of Pac-Man, where the horizontal distance is less than the vertical distance this time around. Now, because the target Y of Pac-Man is less than the coordinate Y of the ghost, we will make the ghost go down first. And in a very similar fashion, where our Pac-Man is upwards from the ghost. So if the horizontal distance is again less than the vertical distance, but in this case the coordinate Y of the ghost is less than the coordinate Y of Pac-Man, we will make the ghost decide to go up. So we will implement all of these conditions in the code. So we are back to the code, and our job right now is to make our enemy decide on its desired direction based on the four cases that we've just discussed. So here's what I'm going to do. I'm going to go to the open space and bring in this orange block to set its desired direction to stay first. And then I'm going to go to control and bring in a big if then else block. And in the diamond-shaped space, I'm going to compare the horizontal distance between the ghost and the target with the vertical distance between the ghost and the target. Now, the horizontal distance between the ghost and the target can be calculated with the difference between the X position of the ghost minus the target X. So I'm going to go to motion and bring in the X position minus, and in the second space, I'm going to bring in target X. So X position minus target X is the difference between the X coordinate of the ghost and the target. Now, if X position, the position of the ghost, is bigger than target X, so for example, if X position is 80 and target as X is 50, then this distance is 30 points, which is correct. But if this X position is 30 and target X is 50, the horizontal distance is 20, but the difference here is negative 20. So we will need to convert that to an actual distance number. So for that, we will use a special operator that's called abs, which stands for absolute value, and I'm going to snap this thing inside. So abs will retain the quantity, how big a number is, regardless of whether it's positive or negative. So abs of X position minus target X is the horizontal distance between Inky's X coordinate versus the target. So I'm going to compare this guy with a very similar thing with the Y position. So I'm just going to duplicate it, and I'm going to snap the Y position inside and target Y. So now I'm going to compare these two. So I'm going to go to operators and I'm going to bring in a less than. So if the horizontal distance with the X position is less than the vertical distance, and I'm going to snap this diamond-shaped block inside. So if the horizontal distance is less than the vertical distance, that means the vertical distance is bigger. So in the first space for the if-else block, I'm going to make the ghost move vertically. Moving the ghost vertically means deciding between up and down, and we're going to decide on that with another if-else block. So if the ghost's vertical position is less than the target's vertical position, so something like that, so the ghost is down with regards to the target, then I'm going to make the ghost move up. Otherwise, I'm going to make the ghost move down. So here I'm going to bring in a simple comparison operator, and I'm going to compare the Y position with target Y. So if Y position is less than target Y, then target Y is upwards for me. So I need to move up. So I will need to set the desired direction to be up. Otherwise, I'm going to set the desired direction to be down. And now in the big L space, we will decide between left and right in a very similar fashion. So we are going to compare the X coordinates this time around. So if the X coordinate of this sprite, of Inky, so if X is less than target X, then that means my target is to the right of me. So I will need to go to the right. Otherwise, I'll go to the left. Alright, so I hope this little script makes sense. If you need to pause the video and go back a couple of minutes where we explained the decisions that we made between up, down, left, and right, then feel free to do so. And if you're still stuck or have any questions, feel free to use the course Q&A because I'm happy to help you. Now, with all this script, I'm going to snap it right before the collision logic. So right after point in direction 90. Alright? So I'm going to snap it like this. Alright, we're not done yet, so let's take a tiny break and let's continue in the next video.